Welcome to the explainer. You know how it goes. You ask an expert a really complex question, and you're just hoping for a straight answer. But instead, you get, well, it depends. It feels like a total dodge, right? A non-answer. But what if it's not? What if it depends is actually the most accurate, most insightful answer possible? Today, we're going to crack the code on that very phrase. We'll turn it from something frustrating into a key that unlocks a much deeper way of seeing the world. So let's get into it.
Right, so this is the big question. Why this phrase? Well, it turns out when a researcher says it depends, they're not trying to avoid your question at all. They're actually pointing you toward a hidden clue, a kind of secret ingredient that changes the whole recipe. They're telling you that the relationship you're asking about isn't just a simple A to B street. No, it's more like a busy intersection with all these other forces coming into play. Today, we're going to learn the real scientific name for this and find out why hunting for it is one of the most important things in modern research.
All right, let's put on our lab coats for a second. When a scientist says it depends, what they're really talking about is something called an interaction effect. I know, it sounds a little technical, but the idea behind it is something we all understand intuitively. It's basically the scientific way of saying that context is everything, and that simple answers just don't cut it in our complicated world. So what exactly is an interaction effect? It's when the impact of one thing on another isn't always the same. It changes based on some third factor. And that third factor is what scientists call a moderator. The moderator literally changes the whole relationship. This is the big idea right here. We stop asking a simple question like, does A cause C? And we start asking a much, much smarter question. Under what conditions does A cause C? You know, the easiest way to picture a moderator is to think of a dimmer switch on a light. The light bulb, that's your main effect. But the moderator, that's the dial. It can turn that light up so it's incredibly bright, dim it down to a faint glow, or turn it off completely. The light bulb itself never changes, but its impact is totally controlled by that dial. That's exactly what moderators do. They don't just act on their own, they control the strength of other relationships. Okay, so we've got the concept down, but really, why should you care? Is this all just a bunch of academic talk? No way. Understanding these interaction effects, these it depends moments, has huge real-world consequences. Seriously, finding them is the key to solving some of the biggest problems we face in our jobs and in our lives. And think about the stakes of these questions. Is a new hiring test fair? Well, it depends on the group being tested. Does having a huge board of directors help a company? It might depend on the company's size or industry. How does that stress from work affect your family life? That probably depends on your personal coping style. See, in every single case, finding that hidden it depends variable isn't just some tiny detail. It's the key to the whole puzzle. And that's exactly why this whole idea is so important. Fields like management and psychology have pretty much moved beyond simple cause and effect models. I mean, today, you would be really hard-pressed to find a major theory that doesn't try to account for these kinds of interactions. The hunt for the it depends has become the absolute gold standard for top-tier research. But here's where our story takes a turn. Just when scientists were realizing how absolutely critical these interactions are, they also found a massive problem. The very tools they were using to find them, well, they were flawed. A lot of them were just plain broken. And this created a huge dilemma for researchers. How are you supposed to find the most important clues when your magnifying glass is all blurry? So, in the world of scientific research, there are two big mistakes you can make. The first is a type 1 error. You can think of this as seeing a ghost. It's a false positive. Your analysis tells you there's an interaction effect, but in reality, there's nothing there. But the second one, a type 2 error, is arguably way worse for science. This is missing the clue. This means an interaction effect is real. It's out there in the world, but your methods just aren't powerful enough to see it. So you conclude it doesn't exist. You literally walk right by a buried treasure chest and never even knew it was there. And this is where that dilemma gets really serious. It turns out, many of the most common statistical methods that researchers have used for years are famous for having low power. Or, in plain English, they're just really bad at finding the clues. This means that for decades, who knows how many researchers were looking for these important effects, finding nothing, and thinking they didn't exist, when really their tools just weren't good enough to spot what was right in front of them. And listen, this isn't some new worry. Way back in 1991, years before our source article, researchers Hall and Rosenthal put out this really stark warning. They basically said that our scientific progress is completely tied to how well we can understand these moderator variables. And if our tools for finding them are flawed, then the advancement of the whole field is, as they put it, severely hindered. It's a powerful reminder of how getting the methods right is everything.
So, what do? Just give up? Thankfully, that's not what happened. Faced with this huge problem, the scientific community did what it does best. It got to work and started forging better tools. Over the last couple of decades, researchers have come up with brand new strategies and much more powerful techniques to hunt down these sneaky but absolutely essential interaction effects.
So, how'd they do it? They basically rethought the entire problem, and they came up with 3 major breakthroughs. First, realizing you need a strong signal to even begin with. Second, finding better ways to analyze how groups work. And third, borrowing some really powerful tools from other areas of statistics. Let's break each one down. So the first big idea comes from William M. Rogers, and it's just brilliant. He showed that there's a basic mathematical rule at play here. You can't have a strong interaction effect if the original thing you're trying to moderate is super weak or doesn't even exist. It's like you need a big fire before you can start trying to moderate the flames. This totally refocused researchers. Before you go hunting for some complex interaction, you have to make sure the main effect is actually solid.
The second breakthrough solves a classic headache for researchers. People work in teams, and those teams work inside bigger companies. So how do you measure an effect that crosses all those different levels? The answer was a much smarter statistical tool called hierarchical linear models, or HLM, that's specifically designed for this nested data. It lets a researcher see how, say, a really positive team culture might turn up the volume or maybe even cancel out the effect of a stressful company-wide policy on one person. It's built to see the interactions between the big picture and the little one.
And the final breakthrough gave researchers an even sharper tool, especially for controlled experiments. You see, old methods often had a problem with measurement error. That's all the statistical noise that can hide a real effect. But by using this more powerful technique called mice, researchers could essentially filter out all that noise. And that lets them see the true interaction effect much more clearly, which means the results are way more accurate and trustworthy. So, case closed, right? We've got better tools, problem solved. Well, not quite. Like any good detective story, solving one mystery just opens up a bunch of new questions. The work of understanding interaction effects is always evolving. The search is definitely not over. And this roadmap for the future just shows that the hunt is getting even more sophisticated. Researchers are now designing their studies from day one specifically to find these interactions, not just hoping they trip over them. They're borrowing cool techniques from other fields, like biology and economics, and they're constantly pitting their tools against each other to see which one works best for a specific job. The point is, the science is always pushing forward, always getting better at finding those hidden variables that really shape our world. And that brings us right back to where we started, with that simple little phrase, it depends. Except now you know what's really going on behind it. You know it's not a dodge, it's an invitation to think a little deeper. It's a signpost pointing you toward a hidden moderator, some factor in the context that changes everything. So I'll leave you with this thought. The next time you run into a tough problem and the answer seems to be, it depends, what hidden dial, what crucial moderator will you start looking for? Because finding it just might be the key to the whole thing.